Hey everyone, hope you're doing all right. In this video, I'm going to be going over rotations in case you missed class or just wanted to go back and learn some more about rotations. In a rotation, all right, so think about what the word rotate means. You're turning it, it's moving around in a circle, all right? There's a couple things you're going to be given. You're going to be given an angle, all right? So you're going to be rotating a certain amount of degrees. You're going to be given a center of rotation, which for us is always going to be the origin, all right? If it's ever not the origin, I made a mistake. And a direction, okay? So directions are either going to be clockwise, so clockwise is this way, or counterclockwise. Counterclockwise is that way. So you got to, think about how the hands on a clock move. And that's what you're going to use to rotate the figures. So when you do a rotation, the pre-image and the image are equidistant from the center of rotation. So it's not changing, how far away it is from the origin. It's just kind of moving around in a circle. Equidistant means equal distance, so the same distance. So we're going to go over a couple of these. Now, for all of these four that we're going to do here, we're going to be rotating clockwise, all right? So remember, clockwise is this way, okay? So if it says 90 degrees clockwise, we're moving this way, all right? We're only going to be rotating these four angles right here, 90 degrees, 180, 270, 360. Well, really not even 360, but I just threw that on there to talk about it. But basically, because 360 divided by 4 is 90, so each time you add 90 degrees, if you notice all of these are multiples of 90, you're really changing to a new quadrant in which you're rotating, okay? So 90 degrees would be like moving here, 180 degrees would be moving 2 quadrants, 270 would be moving 3 quadrants, and then 360 would be moving 4 quadrants back to the quadrant you're in. So the only thing that you need to remember about rotations, okay? You need to know how many quadrants you're moving based on the degrees, okay? So 90 degrees is 1 quadrant. The other thing that you need to know is that every time you go into a new quadrant, X and Y are going to flip, all right? Now, I'm talking about purely the number, okay? Because obviously when you go into different quadrants, what's negative and what's positive might change, right? So if we move down here into this quadrant, we've got a positive x-axis and a negative y-axis, whereas originally we have a positive and a positive. So you gotta think about it like you would think about, I'll just do an example and show you, okay? But basically the numbers are flipping every time. So if you're doing a 180 degree rotation, that's 2 quadrants, so you're coming back to X, Y again. Now, naturally, like I said, they're both negative. So the signs are changing, but you don't need to worry about that because as long as you know what quadrant you're gonna be in, which is based on the angle. So we're gonna do this one real quick. So we're gonna look at these points, okay? Now, so let's start with D. D is 7, 3. So that means it's going to flip to 3, 7, right? So that means its X value will be 3 and its Y value will be 7, right? So we're going over 3 and down 7 because we know it's got to be in this quadrant, right? So the fact that it's positive 7, we're not going up because that's going to take us up here. We know we're not rotating up there, right? We're rotating down here. So we're just counting 3 in this direction and 7 in this direction, all right? So we do that, and so we get a 0.37. We get that point right there. Then we've got 10, 5, so that's going to switch to 5, 10. All right, so that's going to be right here. We've got 2, 4, so that's going to switch to 4, 2. Now, the only one that's tricky about this one is A, because A is actually in this quadrant. right, on the left. So A is actually only rotating to this quadrant. So it's going to be a quadrant behind all of the other ones. So what that means is, so it's 1, 2, so it's going to be switching to 2, 1 like this. All right. And so now we can make our shape. And there we go. So we have a 90-degree rotation. So it's not just changing quadrants, it itself is also rotating 90 degrees as it goes along the circle. All right, so you can kind of see how this way it's flat, whereas now it's tall and skinny because it's turning as it goes. So that's how you do 90 degrees. 180 degrees, all right, so this time we're moving 2 quadrants. So again, notice when we move 1 quadrant, it switches. When we move 2 quadrants, so every time we go into a new quadrant, it switches again. So since we're going 2 quadrants, it's switching to YX, then it's switching actually back to XY. So all of these points are going to switch back to their normal numbers. So this time 7, 3, so we're going 7 in the X direction, 3 in the Y direction, so that's going to be right here, all right, over 7, down 3. We've got 10, 5, so we're going over 10, down 5. Actually went too far, there's 5. We got 2, 4, so we're moving over 2, down 4. Now remember, A is 1 behind all the other ones, so A is going to be 1, 2, but it's only going to be in this quadrant right here, 1, 2. And again, now that we're done, we can draw our lines. And there we go. So we've got a 180-degree rotation. So again, notice it flipped back to being fat and wide, all right, and short, because it's rotating around. So you can look at the picture and you can, if you put them all in the same one, you can kind of see how it's rotating around to make a circle. I'll do that at the end, but 270, right? So 270 is the same thing. We're moving 3 quadrants, all right? 1, 2, 3. Now, it's also the same as moving 1 quadrant counterclockwise. So if you want to think of it that way, you can. But basically just know that we are going to be ending up in this quadrant. And since we're moving 3, that means it's switching back to YX here. So we're going to have all of our points with the opposite thing. So this time we got 7, so D, 7, 3. So it's going to change to 3, 7. So we're going to go over 3 and up 7. Then we've got B, 2, 4, so that's going to change to 4, 2. So that's actually right on A right there. We got C, 10, 5, so that's going to move to over 5, up 10. And then again, A is 1 behind, so A is going to be down here. All right, so that's going to be, right now it's 1, 2, so it's going to switch to 2, 1. And there we go. All right. Oh, we've got a 270-degree rotation, so it's almost back around to where it started. So if you look at all of these, you can kind of see, all right, it's rotating, then it rotates to this one, then that rotates to this one, and then, so 360 is actually moving back. So when we say 360 degrees, all right, that's actually staying exactly where it is, okay? I don't know if you know, like a 360-degree rotation is a full circle back to where you started. So a 360-degree rotation is the same as a 0-degree rotation. So a 360-degree rotation, we call the identity transformation for rotation because, you know, it's going back to where it started. So it's not actually changing at all. So those are the only rotations that we're going to talk about in this class in terms of actually doing the rotations. What the heck? Anyway, so let's do this, okay? Using the figure on the right, state the image of each transformation. So this is kind of just conceptual thinking, all right? It's not actually like doing a rotation with a shape, but we got 90-degree counterclockwise rotation of segment GQ. So segment GQ is right here, okay? So counterclockwise, all right, that's moving this way, and if it's moving 90 degrees, remember that's a quarter, so it's moving a quarter of the circle, and so it's going to end up right here. So what segment is that? That's segment EQ. So you just got to think about like how it's turning. So this one says 135-degree counterclockwise rotation of triangle CDQ. So let's think about that here. CDQ, all right, is that triangle. Now, what is 135 degrees? Well, if you don't know, you can always divide by 360, all right? So if we do 135 divided by 360, we get 0.3758. I don't know if that helps at all because you guys might not know what fraction that decimal is, but if you look, all right, we have 1, 2, 3, 4, 5, 6, 7, we have 8 pieces. So I think this is actually 3 divided by 8. Yeah, it is. So if you tried to simplify that fraction as far as you could, it would be the same as 3 divided by 8. So basically what this is saying is it's going to be moving 3 triangles out of the 8 over counterclockwise. So that would be 1, 2, 3. So that would be moving to right here because we know that's the counterclockwise direction. So what triangle did we end up in? We ended up in HQA. So that's kind of how you would do that question. Then they do a reflection here. Reflection of FQE. So let's see where FQE is. FQE is right here. All right. Reflection of FQE across line GC. So GC is this line right there. So if we reflect across that line, it's just going to go across it. So we're going to end up in this triangle right there, which is ABQ. Okay, so that's kind of how you do this. Just think about it, try your best. If you have questions, you can always ask me. The last thing we're going to do, we kind of did this with line symmetry, but it's rotational symmetry, all right? So a figure has rotational symmetry if it can be mapped onto itself with a rotation of 180 degrees or less. For example, a square has 90-degree rotational symmetry because a rotation of 90 degrees maps a square back onto itself. So 90-degree, that's a quarter turn, right? So if you turn it a quarter of the way, so for some reason they're showing you half of 90 and then half of 90, but I guess it makes sense. You can kind of see how this point is kind of moving up to here, right? And then when it goes 45 more degrees, it goes back. So this point ended up being this point after you rotate it. So it's kind of turning around in a circle. So do any of these have rotational symmetries? So they got to look the exact same. So this one does, okay? If you think we've got 3 circles, so it can turn so that this circle moves to the place of that circle, this circle moves to the place of that circle, this circle moves to the place of that circle, and they'll all end up, the shape will look the exact same. So it's divided into thirds, all right? So if you don't know what degree that is, if it's divided into thirds, so it's making a third turn, what's 360 divided by 3? That's 120. So this actually has a symmetry of 120 degrees. B, does B have any symmetry? The answer is no. B is no symmetry, okay? It's not the same on top as bottom or left or right. So the only way that this is gonna look the same is if you go 360 back to where you started, but we know that symmetry is 180 or less, so that one's no. C has a lot of symmetry, okay? So remember, the closer it is to a circle, the less it has to go. This only has to go to look the exact same to right here, right? So how many spokes are there? There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8. So when it's turning just this much, it's going 1/8 of the way around the circle. So if we want to see what symmetry that has, that's 360 divided by 8. That is 45 degrees. So this is 45-degree rotational symmetry. If every time it rotates 45 degrees, it's looking the exact same. And last but not least, this thing, so because it is a square, but because of the shadings, all right, we can't say 90 degrees. However, this one actually will be the same if you rotate it 180 degrees. All right, so it can do a half turn, because if you look at the triangles, this triangle, if you rotate it 180 degrees, will be in the same spot as this triangle, and that one's going to be in the same spot as this one. So it is going to look the exact same after 180 degrees. So that's basically everything that we're doing today. I want you to try on your own, all right, these 3 questions. Now, right now there's not a graph here, so something got messed up, but by the time you get it, I'll have it fixed and you will have a graph. So go ahead and try these 3 questions, all right? If you want to know if you got them right, you can always come ask me, but or message me and I'll send you the answers. But if you have any questions, let me know, and have a great day.